There you go. Okay. Bom dia. Oh, come on. Let's go. Bom dia. I would like to thank Fisl for inviting me here today. My name is Brian Prophet. I am the community manager for the Overt project, which I will be speaking about today as part of my discussion about elastic overkill. And is the cloud really going to be the great solution, the be-all, end-all, as we say in English, for everyone? I hope that my talk will prove to be interesting. I hope that my odd sense of humor will also prove to be interesting. And I'm really happy to be talking about this morning. And my information is there. And we'll have time for questions when I'm done talking to you today. So, it's all about the cloud. Everything we hear today is cloud, cloud, cloud. Okay? It's everywhere. And it's being presented as a solution to almost every business problem imaginable. You need more storage, use the cloud. You need more processing power, use the cloud. This, in some ways, makes a lot of sense. But I'm here to tell you that that might not be the only solution for your institution or organization. There are other ways of going about getting the computing, storage, and processing power that you need for your applications without necessarily going full bore into the cloud. Now, the reason why I think the cloud is such a pervasive issue in IT right now is Amazon.com. And I know we have Amazon.com.br here. And I blame them because this is their fault. Once upon a time, Amazon.com looked like this. Now, some of you may be too young to remember that this is what the internet looked like. It was gray with black text and maybe one picture, if you were lucky. This is Amazon.com in 1995. This is before it began to sell anything but books. This is before anything remotely like cloud. And you probably heard this story before, but it bears a little bit of repeating. Much of what we refer to as cloud computing, or as it's also known, utility computing, comes from the business case that Amazon had. Every Christmas or major holiday buying season in the United States, it's traditionally Thanksgiving. Right after Thanksgiving, before Christmas, we have a huge buying spree in the United States. Other countries, they have different cycles. But Amazon had a problem because between late November and Christmas in December, the traffic on their website was huge. And they had to add more servers, more routers, more network capacity to handle that. This is not a new story. And then, of course, after Christmas, when everything died down, here they had all this hardware left sitting there doing nothing. So they had the bright idea, and they said, hey, why don't we rent space on these servers? Take advantage of these things, these machines that are just sitting there all year long, not doing anything, and we can make some revenue off of that. And that's exactly what they did. And this is where we get Amazon Web Services and all the different services that subsidiary of Amazon provides, such as Elastic Computing 2, and S3 and all the other services they have. Now, what makes Amazon and all cloud computing unique is elasticity. And this is actually where people get a little bit muddled about where, what is the difference between cloud and what is the difference between just virtualization. And I'm going to explain that. It's elasticity. Elasticity makes cloud. And elasticity is the process of automating your resources so that when you need more compute power, when you need more servers or more storage, a human being doesn't just say, okay, turn it on, let's go. The application itself, the management tools themselves within the cloud will actually automatically pull resources in and push them out as needed. That is what makes cloud, cloud. And it's a very interesting and useful case because in the case of Amazon, in the case of other major shopping sites, in the case of media providers such as YouTube or Vimeo, they are going to need compute power to distribute either their goods or their media content at speeds that human beings could not keep up with. So they need the cloud. But what about everyone else? You may also need to scale your systems. You may also need to get more servers going, but you don't need them that quickly. The classic example I have is if you are a university IT administrator, you are going to only need to have more servers at a very slow pace. The physics lab needs more machines to run so they can do some analysis of some high-end energy collisions. Okay, when do you need them? Well, next week. Okay. And that's human speed. You're still scaling. You're still adding servers, but you're doing it at human speed, not machine speed. Now, I would make the argument that when we're talking about all of this, whether we're talking about virtualization or full cloud computing, size does not matter. Whether you're an enterprise company, a small startup, a consumer who's using this kind of technology for their own use, okay, it's still all the same in one big respect. There's one of you, and there's many of them, the customer, the user, okay? The difference here is, so it's all about scale. I have something that you want, okay? I'm one person, you are many people. Here, it's easy. I just stand up here and wave my hands around and talk, okay? If I'm giving you an application or I'm giving you goods and services, I have to do more than that, okay? So it's not a matter of scale. It's still the one-to-many thing. What the issue is that we have to do it at certain speeds. How fast do we have to do this? And that is the question you really need to ask yourself if you are approaching cloud computing. How do you scale? Or more accurately, how fast do you scale? That is the question that needs to be answered. Now, let me be very clear. I have no real problems with cloud computing. Obviously, working with Overt, which I'm about to kind of describe, I'm a little bit biased towards more of a virtual solution. But cloud computing has its uses, and if you need it, get it. But don't spend the extra time and the extra money if you don't need it. This is the critical thing. So, That was cloud. Welcome now to virtualization land. Okay? Because all of this is really, whether you're using cloud or virtual data center management, this is all based on virtualization. Okay? And virtualization delivers a lot of wonderful advantages. Not the least of which is, obviously, if you have more virtual servers than physical servers, you're saving on hardware. You're saving on energy. You're saving on maintenance, and so forth and so on. Your time to deploy should be faster. Your time for maintenance should be faster because you don't have to take a whole big iron box offline to maintain it. You can switch off your machines to other boxes, keep them running, and then take the hardware and replace or repair it or whatever you need to do. So there are huge advantages to virtualization. Many of you probably have seen something like this. So this is not new, and I won't dwell into this too much. But on the left is the old way, where you have one operating system per server. And within each server, hitting that operating system, whether it's Red Hat or Ubuntu or Windows, sorry. But I need some time there. No, it's okay. It's all right. But whatever your operating system is, you have one per server. This is the old way. All of your applications talk to the operating system, and everything is good. On the right is mostly what virtualization is about. You have many operating systems that live inside a virtual hypervisor layer inside hardware. And each one of those guest operating systems has their own set of apps that hit them, whether, again, it's Windows, Red Hat, SUSE, Ubuntu, whatever, okay, or CentOS. So that's the new solution. And the advantages are clear. You have the easier migration. You have a better return on your investment. Okay? Curiously enough, one of the big differences between cloud, and cloud is exactly like this, by the way. This is cloud 2. However, what cloud adds to this is management and deployment software that automates the whole thing, so you as an administrator don't have to worry about it. If my application starts screaming for help and says, I need more resources, the application will talk to the management layer, and then that will pull in the resources automatically. That's the only difference between what plain virtualization, which is what I have here, and cloud is. Well, not the only difference, but the only real big difference that I want to talk about today. So with virtualization, as I mentioned, you have hardware consolidation, you have fewer servers, you can have fewer, bigger servers. Workload management becomes easier if you have services that find themselves being oversubscribed. They will get more hardware resources as needed and more virtualization machines as needed. Applications benefit from virtualization because you can move machines around onto hardware that is actually not having any problems, you have fault tolerance, you can have high availability, you can have live migration, quality of service. With a sophisticated tool, which I might be talking about in a moment, you can also have network definition and disk management and storage and compute. So it all really kind of wraps up together. These are some of the, and this is all to the benefit of the application. You can have resource scalability. So I add one hardware box and I can have, up to 10 or 12 or however many virtual machines running on that hardware system. And I can modify those systems on the fly. As I described earlier, if I have a hardware server that's going down and is throwing off problems, I can quickly move my virtual machines to another physical host, let them keep running, and take my hardware off and deal with whatever problem that's there. Another advantage that virtualization provides, because the applications are still only talking to the operating system layer, you don't have to change the applications. You may have to do some tweaking as far as if your applications need a little bit of reconfiguring as far as networks, but that's basically it. As far as your application is concerned, it's running on the same version of Red Hat or CentOS that it was running on before. You don't have to recode it. That is actually a big problem when you go to the cloud. If you have to go to cloud computing, and if you need to go, you need to be prepared for the fact that you're probably, to take advantage of the cloud, you're going to have to rewrite your applications in some way so that when they have problems, when they need resources, they can talk to the cloud API layer and start pulling in the resources they need. So those are some of the advantages of virtualization. There are lots of virtualization tools that are out there. We have Overt, which I sort of like. We also have Zen, which has been with the Linux Foundation since last April. It's a very widely deployed hypervisor. It is mostly commercially sponsored by Citrix. Zen is a really good product, and I don't know how many people here actually use Zen. Okay, a few of you. You can stay. It's okay. But it's a very good hypervisor. It's different from Overt because Overt is based on another hypervisor called KVM, and we're all about KVM with Overt. But we still like to talk about Zen because they're a valued part of the open source virtualization community, as is the third one there, Ganeti. Ganeti is very new. It's, I would say, rough. It's been developed by Google so that they can manage their own clusters, and it has the capability of managing both KVM and Zen hypervisor systems. I've never actually worked with Ganeti. I've seen it in action. It's not pretty yet, since it's so new, but it actually has some promise, and it looks to be an interesting piece of technology. But I'm here to talk about Overt. I even wore a shirt, so it's all, I got to talk about it. So Overt is, if you're not familiar with it, it is a large-scale centralized management solution for server and desktop virtualization. So basically think of it this way. If you have virtual machines, more than one, actually, and you can have anywhere from 2 to 1,000 or more, depending on what your needs are. Overt will basically take those machines and help you organize them and manage tools within those virtual machines in such a way that your life becomes a lot more easier. It is very scalable. One of the misconceptions about virtualization management tools such as Overt is that they really don't scale. If you want to scale, people say, go use the cloud. No. If you want to scale really, really fast, then sure, use the cloud. But if you want to scale, you can certainly use a tool like Overt. We have all of the leading performance, security, and infrastructure tools in there that make scalability pretty easy to do. One of our users that we know of, one of the largest users, is a German host provider. They are using Overt in production, and they have 1,100 virtual machines running with 70 hypervisors. So that's pretty big. And they're doing quite well with Overt. If you are at all familiar with VMware vSphere, we are pretty much the open source and free software alternative to VMware vSphere. The advantage there is we are obviously a free software project, so expenses go way down. Because I don't know if you've ever used vSphere. It's an okay tool, but it's really expensive. So, and also, just so everybody's familiar with it, we are a community project. Like many other projects that Red Hat sponsors and really helps to drive, it is an upstream open source project. It serves as the upstream project for the commercial project that's downstream, which is Red Hat Enterprise Virtualization, or REV for short. So if I say REV, that's what I'm talking about. Okay, we do that a lot, actually, at Red Hat. If you're at all familiar, I'm sure many of you are familiar with Fedora. Fedora is the upstream community project for Red Hat Enterprise Linux, or RHEL. And now with our new partnership with CentOS, CentOS becomes downstream of RHEL. So we have 3 layers there. We go from Fedora to RHEL and then CentOS. So it's been really exciting to have CentOS come into Red Hat in the last few months because we, especially at Overt, love to have a free enterprise platform to show off what we can do. So that's been a great benefit. But our community is strong in and of itself. We have a couple of hundred talented engineers all over the world, very dedicated to making Overt work. We have a lot of outside contributions as well from companies such as IBM and Hewlett-Packard, to name a couple. We have people contributing all the time. We have a very vibrant and active mailing list and IRC channel, which sounds kind of, whatever, but that actually is important. Because if you are using Overt, especially if you want to use it in a production environment, then having your questions answered quickly is a great thing. And my team of people are men and women who will very committed to getting the community the resources they need. And I am committed to helping them do it better. So we're making a lot of progress there. If you've never seen Overt before, this is Overt 3.3. We've just released Overt 3.4, so it looks slightly different than this. It's a little hard to see on the screen, but on the left you have a navigation bar where you can sort of pick and choose the resources that you want. Across the top, it's basically, you have tabs that will let you go into and manage whatever part of the data center that you're working at. So you can create an entirely new data center, the whole thing, with just a few clicks. And you can bring it up and down with just a few clicks. Or you can go all the way down into the individual disk systems and mess with that. So huge or small, whatever you need to manage, you can do it with Overt. Now, this big piece of complicated diagram is really what the architecture of Overt looks like. Now, I am not going to explain every piece of this because I would like you to stay awake and keep yourself going for the rest of the day. But I do want to point out to you that this structure actually has some meaning to the conversation that we've been having about cloud computing. And this is what I'm about to tell you now is the big answer to the question that I always get. Well, you work with Red Hat, right? Yes. You have Overt, right? Yes, but you're also involved in OpenStack, which is cloud computing. Aren't you competing with yourself? No. And that's really what this presentation is all about. We are not competing with ourselves because what this is and what cloud is are two ends of a spectrum. And you as the user can decide what you need. So to walk through this, I'm just going to hit the highlights really quickly and not go into too much of this. So on the top, highlighted there, is the Overt engine. It is based on JBoss and Java. I have another talk later this week where I talk about the beginnings of Overt. It had a very interesting start. And its community, because of that, we have an interesting community. This actually did not start as a Java-based application. This was a .NET-based application. This was Windows. Ugh, sorry. I know. I'll get over it. But it was. And for the first year or so of its life, Overt was purely a commercial, proprietary, Windows-based product. Don't throw things at me. It's all good. We changed, okay? Because Red Hat came along and bought the company that was making Overt and turned it into Rev, and at the same time, for about 2 years, spent all their time changing the Overt engine over to a Java-based solution that is actually free software. So that was good. What the engine does, it helps manage the virtual machine lifecycle. It's controlled. We have several ways that you can get into it. What you saw on the screen earlier was our web administration portal. We also have a web-based user portal. So if you want your users to be able to use Overt and pull up their own machines based on permissions, of course, they can go through and give themselves whatever machines they want, which is a nice way of handling it. There's also a REST API that you can use that and build your own plugins to talk to Overt. And also there's a Python-based software development kit. And of course, we have command line interface because we do run with Linux, and you have to have CLI because that's the way Bash runs. So those are some of the ways that you can talk to the engine. And that becomes important because Overt, we want developers and administrators to be able to talk to our engine and get it to do more things as they need it. Highlighted on the bottom right is the node. The node actually can be two things depending on what you need it to do. It can be, it's a standalone hypervisor. That's always what it is. But it can be a small hypervisor that's just sort of based, it's just enough Fedora or CentOS to run a virtual machine and nothing more. It's very small. It's only about 170 megabytes. So it doesn't take a lot of resources. And it'll run on any hardware that RHEL and CentOS can run on, as long as it has processors that directly support virtualization, like Intel VT or AMD V, either one of those. It's pretty easy to install by itself. A lot of people just use our node and not the entire engine package. And it can boot by USB or Pixie boot or right onto your hard drive. It can also, if you want more, it can be a full host and have a full Fedora or CentOS distribution running on it if you need more than that. So it's very flexible either way, however much power you need the node to have. Storage, we have a lot of shared storage options. We can use Fiber Channel, NFS, iSCSI, POSIX-based storage, so we can plug into Gluster. We can also plug into OpenStack's Glance storage tool if we wanted to. So whatever your storage needs are, we can pretty much match that and get your data to your application without too much trouble. Now, looking back at this, I've got this set up. If any of you are at all familiar with cloud computing, and if you are familiar with OpenStack, this might actually look familiar to you. You might be saying to yourself, this seems like something I've met before. And if you're not, that's okay, because I can kind of walk you through it right now. This is what a very simplified diagram of OpenStack and how it works. OpenStack, like many other projects like Overt and other open source projects, is not monolithic. It is modular. There are pieces and parts of it that are all tied together and they work as a cohesive unit. So we have the dashboard. We have compute, which is handled by Nova. Networking is handled by Quantum. Imaging is handled by Glance, and so forth and so on. Looking at a diagram like that, there are a lot of parallels between what's going on here in OpenStack and what's going on back in Overt. Because now you have a lot of you have these components that are actually sort of matching up. And this is actually key to my conversation today about scalability and speed of scalability, because at the fundamental level, even though they're using different pieces of software and different programming languages and slightly different ways of doing things, fundamentally, OpenStack and Overt, one is cloud computing, one is a virtual data center manager. They have many of the same tools. Our engine is the equivalent of OpenStack's dashboard. Our node is the equivalent of OpenStack's compute node. Our storage practically is plug and play. We can take one out and pop the other one in. They pretty much talk the same way. We have our own reporting tools there on the left and our own identity management, just like OpenStack. We are not better than OpenStack. We are different from OpenStack. We're still only doing, virtual data center management. We are not doing cloud. We don't have elasticity. But fundamentally, our architectures have a lot of similarity. So I have a small, this table sort of shows how much commonality we have. So Overt is all about scaling up and all about scaling out. So I don't know if this metaphor is common here in Brazil, but what we say is Overt treats servers like pets, and OpenStack, a cloud server, treats them like cattle, because you're moving a lot of cows around and getting them to do the same thing. So if you're a vegetarian, I would offer another metaphor and say, Overt is like growing, tomatoes or potatoes in your own home garden, and you love this. You grow these wonderful fruits and vegetables, and then you take them inside and you wash them and you eat them. And yes, I'm very hungry right now. Okay, sorry. But OpenStack is like a farm. I have soybeans, I have corn, I have wheat. Okay, so if you're a vegetarian, that's the metaphor that you should use, and not the pets and the cattle thing. Either way, it's the same thing. Servers can be treated with greater care with Overt because that's what you need but with a cloud solution, you're more concerned with the application, and servers are just massive tools that you're just going to grab, use, and then pitch when you're done. Overt has high availability, so they're expected to stay up all the time. Even though Overt can scale, you need to have that high availability built in because we want to make sure that those servers are still running. Whereas OpenStack has stateless VMs, which means we basically need to have redundancy built in. Hello. But then, as you can see, there are a lot of similarities as you go down. Now they both have resiliency. They're both using shared storage. They both need to define their own virtual networks. They both have their dashboard. That's the commonality. So some differences, but a lot of things that are in common. So this is why we sort of say Overt and OpenStack really do not compete with each other. Because with Overt, you can have virtualization now if you need it. If you're at college, and I always fall back to college because I teach at a university part-time, a college doesn't need elasticity, usually. If I add more students to the college, great. But I'm going to add servers at a reasonable human pace. But if, for instance, the college decides to get something like a new high-energy physics lab, and they need some research systems that need to have elasticity and scalability, you can use, like with Overt, you can swap pieces and parts away, and you can move to a cloud-based solution pretty quickly, so you can have your cloud later and migrate to OpenStack. Remember, it's not competing, it's two ends of a path. And if you, wherever you are, that's where you can find a solution. And we have some of those now. We actually have specific tools. So as I mentioned, our storage in Overt goes, talks to Glance for imaging and talks to Cinder for storage. And these are the exact same tools that are used in OpenStack. Our node will talk to OpenStack's Neutron tool for software-defined networking. And we also have a Nova driver. Our engine will talk to OpenStack's Horizon dashboard. And our identity tools can be shared with OpenStack's Keystone identity. So we're actually already there and moving there more every day. So we're very excited about Overt. I hope I've given you enough of an introduction that you would like to look at it yourself and talk to me about it out in the hall after we're done, and hearing questions if you have any. Overt, we like to say we have one path to performance. So whatever you need, whether it's virtual machines that just need to just hum along and do their jobs, or later if you need actual cloud elasticity, you're not locked in. You can move from one solution to the other with ease. So with that, I believe I've talked long enough. So I would like to open it up for questions and answers, and thank you very much. So if there are any questions, see this gentleman over here, and he'll get you the mic. No. You got his mic? Do you want to try this one? There he goes. There he goes.
I think people can hear me. Hello?
Yes, go ahead.
Okay. So can you say that the general use case for Overt would be like in a legacy application that you can't go to the cloud or go to a open cloud that you can host yourself? Because in a legacy application you won't have this kind of worry about scalability and redundancy mainly, I think. So can you say that's a good option? Like I have like these bare metal machines and I want to virtualize, so go Overt for my legacy applications?
Yes. And that's one benefit. I sort of mentioned that earlier in the talk, but I didn't actually apply it to Overt, and that was a good catch because I missed that. One of the reasons why you would want to use Overt as opposed to a cloud solution is exactly that. You can take your legacy applications and run them, out on a KVM-based machine without any problems whatsoever. No recoding, nothing to worry about. You just have to basically redeploy them onto your virtual machines and you're done. So that's a big reason why specifically people turn to tools like Overt, like XenServer, like Ganeti. To be fair, I'll talk about them all. That's why they go to those solutions, because when you go to the cloud, you can use your legacy applications in the cloud, but you don't get cloud. It's like you're paying for all this stuff and you're not using it. So, I'm sorry, you have more?
No, sorry. I have one other question.
Uh-huh.
I think that's a little off topic, but I wanted to know what you think about the Linux container. Mainly, it's not about hypervisors, but using Linux containers like Docker and stuff like this.
Okay,
because
so
they are growing fast, I think.
Can you get my
and they look like they are a good option.
You have talked to the right man. That was a wonderful question because, obrigado, thank you. Okay. So besides working on Overt, so I also, just 2 weeks ago, am now working with Project Atomic, which is Red Hat's new container project that we're working on. We're working with solutions like Docker and Geerd and RPM OS3, and we're talking about containers. So, and I'm one of the community managers over there. So if you want to talk to me about Atomic, I can do it in the hall. But quickly about containers. Containers are a very interesting solution, especially for developers. Maybe a little bit for administrators too. But developers love containers. I don't know if you're familiar with what containers are. They are not virtual machines, but they are basically file-hardened pieces of code that allow an application to run inside them, and all you need instead of an operating system is just the libraries that application needs and nothing else. So they're very small and lightweight. And as far as the application is concerned, it's inside the container. And so if you take that container and go over here, it's happy. It's even easier than a virtual machine because it literally does not care because it's inside the container. A developer likes a container because when even a virtual machine, and we get this all the time, we actually have this problem with Overt. We run on RHEL and CentOS. We also run on Fedora. And while I love Fedora, and I have no problems with that software, Fedora changes all the time. And sometimes that breaks Overt, and we kind of get into little shouting matches with them and say, stop. But they, it's Fedora. They're going to change all the time. To containers, if you're writing an application inside of a container as a developer, you don't care anymore what the operating system is doing. And it's very new, and not a lot of people are working with it. We're working with Docker. They're upstream from Project Atomic, and we're pulling that in. I think it's going to provide a lot of really valuable tools for developers and administrators. How that will fit in the conversation with containers and virtual machines is probably going to be another presentation from me sometime in the very near future because I am wearing both hats now. So thank you for the question.
Okay, thank you.
Any other questions?
Overt runs under another OS Why not make the overt on OS and run the virtual machines only under overt?
I'm not sure I understand the question. So are you saying why doesn't overt run on anything but Red Hat oriented systems?
No. Why not make the overt on OS?
That's a good question. I mean, it kind of sort of is, especially at the node level. It's so tightly integrated on the node component that it actually is an operating system. It sort of acts as an operating system, if I understand your question correctly. And certainly with the commercial product, Rev, that it's very tied into the operating system. But at this point, it still serves us better to have it as a separate application layer or virtual machine layer at this point, because we're still dealing with KVM and libvirt and trying to keep things separate above the operating system layer. But see me after, because I want to make absolutely sure I understood your question right, and get it answered correctly. Any other questions? Ladies and gentlemen, thank you very, very much for your time and attention today, and thank you for being such a gracious audience.